Hello, this is Peter from Educomondo and a warm welcome to our fourth STEAM project. This is the teacher edition, called the traffic lights. Here we teach the teacher how to bring science, technology, engineering, arts and math subjects to your classroom in an exciting and engaging way. The level of this lesson is for beginning teachers and students in the field of STEAM. We call this level the Explorer level. Today we are going one step further in controlling light-emitting diodes with our microcontroller. Instead of working with one LED, we will be working with 3 LEDs and make them go on and off in a particular sequence and a particular timing, just like a traffic light. In this lesson we will teach our students a more complex breadboard setup, practicing the for loop, finding solutions while collaborating together as a team. Start by splitting up your class into small groups of about 3 students and hand out the following components from the starter kit: the project board with the microcontroller and the breadboard, a red LED, a yellow LED, a green LED, 3 resistors of 220 ohm. We will also need 4 jumper cables with different colors. I advise to use the same colors as the LEDs, as that will make life easier later on to build and maybe even troubleshoot a project. We will also need 3 of these pre-formed wires. And as always, the most important, the traffic light cardboard figurine. Let's start building the project. In this lesson, we introduce a new way of visualizing the project. By showing this image, you can explain to your class how to build the project. You can keep this drawing projected on the whiteboard or keep it on your computer for their reference. This will allow your students to go faster, because by now they have experience in building a circuit on the breadboard. Only using the drawing, explain to your class how they need to build this project. First, put the 3 LEDs closely together so that the traffic light cardboard will fit. Attach the resistors to the positive legs of the LEDs. Connect the LEDs to the Arduino. Each of the LEDs will need a digital pin to receive the command to go on or off. The red one goes into pin number 7, the yellow one goes into pin number 6, the green one goes into pin number 5. Use the small connectors to bridge towards the ground rail of the breadboard and connect it with the black wire to the ground pin of the Arduino. After we have pushed the traffic light cardboard over the LEDs, the project will look as shown in the video. Check with your students whether they have finished the build and whether they are ready to connect their project board to the computer. If all systems are clear, they can launch the Arduino IDE and open a sketch to start programming. Today's programming is all about simulating a traffic light. The time that one of the LEDs is on or off, or is blinking, should be similar to what you see on a real live traffic light. First, we create a space on top of the program and give our file a name. Lesson number 4, Traffic Lights. The double slash means that whatever follows on that line is a comment. Next we create another comment line, variables, because we know that we will need to declare some variables. And we do that in this space and not somewhere hidden in the code. Because we have used pin numbers 5, 6 and 7 on the microcontroller, we are going to declare the following variables. The integer green pin equals 5, orange pin equals 6, and red pin equals 7. We also know that we will use different timings per color. It is safe to already declare those variables here. Integer dt green equals 5000, integer dt orange equals 2000, and the same for red equals 5000. Remember to always close your code with a semicolon. In the void setter part, we activate our pins by using the command pin mode, and in between brackets, green pin, and we set it to output. The same for the orange pin and the red pin. Remind your class that they have to watch the color of the commands. If it doesn't change, they have written the command incorrectly. Next we go to our void loop section. Digital write, green pin, and we set it high. Followed by our delay, the dt green, and then we set our green pin low again. And this we do for the orange pin and the red pin. Let us upload the program and check whether it works. Our traffic light is doing exactly what it is supposed to do. Watch the green light go on and off, followed by a shorter orange light, and then switching to red. After red, the traffic light switches to green again. What if we want to make this somewhat more interesting and want the orange light to blink 3 times in between switching from green to red? We will use the for command to make this happen. In the void loop section, we replace the digital write orange part with the following for loop. For value equals 0, and for as long as the value is smaller than 3, the value will be replaced by a value plus 1. And then we actually repeat what we had in our previous section. We have the digital write and the delay of our orange pin. Because we introduced a new variable called val, we have to go up again and declare it in our variable section. And here we write int val. Let's break down the code once more so that your class fully understands what is happening. So the value of our variable called val is set at the beginning at 0. It starts at 0. And for as long as that variable does not reach the value of 3, the microcontroller will add 1 to the variable val, and it will execute the command between the curly brackets 3 times. Because we want the orange LED to flash, we need to go back to the variable space on top of the program and decrease the variable DTOrange to 750 milliseconds. Once again, we are ready to upload the program. You can see that the lights are blinking like a real traffic light. This time with the orange giving a warning by flashing 3 times before jumping from green to red. Congratulations! If it works for your class, tell them they did a great job. If not, no panic. Ask them to do some logical fault finding. Did they end all commands with a semicolon? Did they type all commands correctly? Check the color of the commands. Did they put the wires in the right pin? Did they declare the right pin number as a variable? Are all connections on the breadboard firm? Is the LED not broken? Troubleshooting is a great learning moment for your students. Tell them that this is not a failure. They will learn while collaborating together and thinking logically, step by step through their program. This concludes our 4th project, the traffic lights. Time to repeat with your class what they have learned. We learned how to make a more complex Arduino build with multiple LEDs. They rehearsed the for loop, and we did some error and solution finding. Because we experimented with a traffic light, wouldn't it be a great idea to have an assignment involving traffic? Here are a couple of questions that you can ask your students to research. How do traffic lights work in your country? Explain how to safely cross a street with or without traffic lights. Go to the library and look for a book on traffic rules. Create 5 questions on specific traffic situations that your fellow students need to solve. Have fun with the assignment, and I'm looking forward to start with lesson number 5. In that lesson, we are going to learn more about colors and a special kind of LED, the red, green, blue or RGB LED. Bye-bye.